Okay, I just pulled in, so I grabbed a couple of them from your work. So this says if x is 9 and z is 11, find the measure of the angle. So you want to make sure that when you see your triangles, you know if I'm using the regular trig functions or the negative ones. How do I know the difference?
If you're looking for the angle, then you're using the inverted.
Good, exactly. If you're looking for the angle, you're using those negative ones, right? So as soon as you look at this triangle and you see that you're looking for the measure of angle x, hopefully that triggers you to know that you're going to have to use the sine of -1, or the cosine -1, or the tangent -1, based on what information you're given. So this time I give you x, which is adjacent. Side x, which is opposite angle x. And I give you z, which is 11, which is the hypotenuse. And the combination there, so in respect to angle x, which is here, that's opposite hypotenuse, which tells you that it's sine. So then you would say the sine of x equals 9 over 11. And then hit that -1 button, sine -1 of x, or sine -1 of 9 over 11, and you end up with the angle being 54.9. Questions on that one? The second one gave you y, which is one of the legs, and z, which is the hypotenuse. And it asks for angle x again. So this time, in respect to the x, I've got the adjacent side and the hypotenuse, which tells you cosine. The fact that you're looking for an angle should still trigger you to remind you that you're going to have to use those negative ones. So the cosine of x equals 5 over 12. And then in the calculator, I would do the cosine -1 of 5 over 12. And I end up with 65.4. Questions on that one? Yep.
Okay, I didn't use cosine, but I got the same answer.
So did you find the opposite side?
Yeah.
Which was what?
I got x.
Did you use Pythagorean theorem?
Yeah.
Okay. So just be careful there, because you're using then a value that you determined and not that was given to you. It's going to be rounded. It's going to be a little less accurate.
It was 0.1.
So just be careful.
Is that right though?
If you do it correctly,
Yeah,
then it's totally fine. There's a lot of different ways to do these. Like I could have found y using sine, angle y, and then subtracted that from 90, found x. There's like 10 ways to do this.
Yeah.
It's just you want to minimize the error there. So you want to say, stick with what they gave me because I know it's not rounded and I know it's right. But you'll still get the correct answer. And it's a good way to check it. Okay, and then the last one, this time it said to solve the triangle x, y, z. So you had to find all the missing sides of all the missing angles. They gave you that y was 17.4. So if I wanted to find angle x, I would have to do 90 minus 17.4, right? So that's a minus. And I get 72.6 in there. So that's one of the things you're missing. Oh, which is right here. And then when you're solving for, let's say you want to solve for side x first. So that's down here. Side x, I would stick with the information that they gave you, which is that the angle is 17.4. I'm given the hypotenuse. X is adjacent to 17.4, which means it's cosine. So the cosine of 17.4 would equal x over 12. When the variable is in the top, I just have to multiply. So 12 times the cosine of 17.4 gives you that missing side is 11.5. So that's x, 11.5. Alejandro.
If you're only given that the angle is 90, could you use it and like find the sine or cosine of it?
Of the 90?
Yeah.
No. So sine and cosine and tangent don't work on the right angle. They can only work on a cube. Problem is, opposite's the same as the hypotenuse, and you have two adjacent sides, so you can't decipher the difference between them. So you can only do this with the two. You would have to be given, if you're looking for a side length, you're going to be given at least one of the two acute angles. If you're looking for the angle, then you're going to get given at least two sides. So then the next thing on this one was y, and y in respect, I would have still gone back to the 17.4, is opposite. Use the 12 that they gave you, which is hypotenuse. Sine of 17.4 would be y over 12, multiply by 12 on both sides, and I get y equals 3.6. And this is one of those opportunities where you could have checked it using Pythagorean theorem. So I could have done 11.5 squared plus 3.6 squared and see if it was close to or equal to 144, which is 12 squared. And then you would have known you did it correctly. Questions on any of those? Okay, so in the sake of time, I'm gonna do review, and then if we got time, I'll go over the homework from 7-7. If not, we'll do that tomorrow. So kind of quick concept review, the things you need to know for the test, and then your chapter review is your actual homework assignment. So we start with 7.1, which was the Pythagorean theorem. Okay, which is a squared plus b squared equals c squared. Hopefully most of you have mastered this one by now. One of the things that you want to make sure that you check is to make sure that two sides add up to be greater than the third. If that is not the case, then you have no triangle to start with. So if I have the two side lengths being 2, 2, and 5, this can't even form a triangle. If I gave you 3 little strings and one was 2 inches, the other one was 2 inches, and one was 5 inches, there would be no way to connect them end point to end point. You can't do it. Physically impossible. So in this case, there would be no triangle. If it was 2, 3, and 5, would there be a triangle? No, why not? Okay, can't be equal, has to be greater than. And then you just want to make sure the C is the biggest. That's pretty much it. There's not a lot of tricking in here. Seven 7.2 was the converse to the Pythagorean theorem. So this is if c squared equals a squared plus b squared, then it's what kind of triangle? Good. If c squared is greater than a squared plus b squared, then what kind of triangle? Obtuse. And if c squared is less than a squared plus b squared, then it's a cube. All right, 7.3 was similar right triangles, and we started with geometric mean. Which is the square root of the product of the two numbers that they give you. So if I said find the geometric mean of 20 and 16, I would do the square root of 20 times 16, and then I would break these down. So this would be 2 and 10, 2 and 5, 2 and 8, 2 and 4, 2 and 2. And then for every pair of a single number, that number is going to go to the outside of the radical, and whatever's left is going to stay underneath. So I've got 1, 2, 2 2's there, another 2 2's, another pair of 2's, and then a single 5 that's left underneath. So I would get 8 radical 5. Then we had our two proportions, which were segment 1 over altitude equals altitude over segment 2, and hypotenuse over leg equals leg over segment of the hypotenuse adjacent to that leg. And these are all dealing with a right triangle that has an altitude drawn to it. So the big triangle has to be a right triangle, and then the altitude has to be drawn. So depending on what information they give you or what information you're looking for is how you'll set it up. So one of the quizzes had X, and it had 3, and it had 6. So if I was solving for X, my first thing is if I'm looking for X or there's a number on X, what is that segment called that X is? The altitude. So if there's something there that I'm looking for or have to use, then obviously I'm going to use that first one. So I know I'm going to use this segment 1 over altitude equals altitude over segment 2. So this would be 3 over X equals X over 6. And then cross multiply and square root.
That's a 3?
That's a 3, yep. And this is 2 and 9, which is 3 and 3. And I get 3 root 2. And let's say I'm using that same triangle, but this time I want to solve for y. Y is what segment inside that triangle? What do we call that? The side of a right triangle that's not the hypotenuse. It's a leg. So if I'm involving a leg, then I have to use that second one, right? Which is the hypotenuse, and by hypotenuse we mean hypotenuse of the big triangle, which would be 6 plus 3 or 9, over the leg, which is y, equals the leg, which repeats, over the segment of the hypotenuse adjacent to the leg. So which part of that hypotenuse is next to y? 6. And then I'd get y squared equals 54. Square root of 54, which breaks down. Two and 27, 3 and 9, 3 and 3, and I've got a pair of 3s. And the 3 and the 2 would multiply underneath. Okay, then came 7.4. So notice this is still stuff without a calculator. And this was special right triangles. And there's 2. A 45, 45, 90 triangle. And a 30, 60, 90. So 45, 45, this would be A, this would be A, this would be A root 2. 30, 60, 90, this is A root 3, and this is 2A. Okay, so with these, again, no calculator. Maybe you get lucky, maybe you get given the A. Let's say that I gave you this side, and I asked for the other 2. So if I give you that the side opposite 45 is 3, then the other side opposite the 45 is 3, and the side opposite the 90 would be 3 radical 2. So that's the easy part, right? It gets a little trickier if I'm to give you the side opposite the 45. So let's say that this is 22. So I would label, this is A, this is A, this is A root 2, and then I would solve for A. So 22 equals A root 2. I'd have to divide both sides by root 2. This goes away, and then the left side I have to rationalize. So I multiply both the top and the bottom by root 2, and I get 22 times root 2 over 2, which reduces to 11 root 2. And that's your A, which means that is both this side and this side. So same goes for 30, 60, 90. If I give you, whoa, that's ugly. If I give you the 30, the side opposite 30, not so bad, right? But if I give you, let's say I give you side opposite the 90, let's say this is 10. Then I would know this is A root 3, this is 2A. If 2A equals 10, solve for A, and I get A is what? 5, which would be that side. And then this side would be 5 root 3. If I gave you the side opposite this 60, you'd have to divide by root 3 and rationalize it. Okay, so you're going to get given different kinds of information there, Alexis.
How would you do the first one, if they gave you the hypotenuse, which is a square, but they give you like 3 root 3.
If it gives you 3 root 3 for the actual side length.
Like, yeah, because for the hypotenuse, the one that equals a radical 2.
So in a 45, 45, 90 triangle, that's what you're saying, right? 45, 45. They're saying this equals 3 root 2.
No, if it like equals anything other than the root 2. Like, will it?
Yeah, the one I showed you, it was 10. Oh, you mean anything other than like it could be square root 3?
Yeah.
Not gonna do it to you. It's possible, but it's not. Yeah. You would still have to just divide by root 2, and then you have a radical in the top, radical in the bottom. Don't worry about that. So the other two types of problems in this section were the two kind of word problems. Do you remember them? They're special figures that when I do something to them, I get 45, 45, 90, or 30, 60, 90. So what shape do I get the 45 from? A square. If a square has a diagonal, it's 45, 45, right? And if an equilateral triangle has an altitude, it's now two 30, 60, 90 triangles. So there's also problems like that. Questions on any of those? That bell's about to ring. Okay, and then 5 through 7 was your Sohcahtoa. So the good news is we've gotten a lot of practice on these.
So like the quiz stuff.
Nope, you can keep